topic of this video is even-odd functions and symmetry about axes. So testing for symmetry, even functions have y-axis symmetry. When you think about even functions, think about a quadratic function, how it is symmetric about the y-axis, how you can fold it along the y-axis and you'll have two equal parts. So even functions have symmetry about y-axis. Y-axis acts like a mirror for these functions. A function is even if xy is a point on the function, point on the graph of the function, then negative xy is also a point on the graph of the function. If xy is a point on the graph of the function, then negative xy is also a point on the graph of the function. For example, looking at here, we can say, let's say this is 0.33, then negative 33 is also on the graph of the function. So that means if we, f of negative x is equal to f of x. If we replace x by negative x, then the function does not change. If that's the case, then it's an even function and it is symmetric about the y-axis. Odd functions are symmetric about the origin. In odd functions, if xy is a point on the graph of the function, then negative x, negative y is also a point on the graph of the function. F of negative x is equal to negative of f of x. That means if you replace x by negative x, you get the opposite of original function. And that would be symmetry about origin. And here, this graph is symmetric about the line y is equal to x. Y is equal to x acts like a mirror for this graph. X-axis symmetry. Graphs that are symmetric to x-axis are not really graphs of functions as they fail the vertical line test. So these are not going to be graphs of functions. Okay, so here's some examples and we are asking if the function is even, odd, or neither. So to check the function is even, odd, or neither, we can go ahead and replace the x by negative x. If we get the same as original function, then that would be even function. Second thing we can try, we can replace x by negative x, y by negative y. If we get the opposite of original function, that would be odd function. And if none of these two things happen, that would be neither. We can also talk about symmetry of the function then. And a graph doesn't have to be symmetric to x or y axis or origin. A graph can be symmetric to none of these as well. So first problem, we're deciding if the function is even, odd, or neither. If I replace x by negative x, let's see what happens. This is going to be negative x to the fifth minus x. And I can pull that negative out, x to the fifth plus x. So in this case, f of negative x is equal to negative of f of x. And that means if we have f of negative x is equal to negative of f of x, then that is an odd function. And odd functions do have origin symmetry. Odd functions have origin symmetry. Origin symmetry. Okay, next example, f of x is equal to 2x minus x squared. Let's see what's f of negative x equal to. F of negative x will be 2 times negative x minus negative x squared, which is negative 2x minus x squared. And it's not same as original function. It's not opposite of original function. So this is going to be neither. This graph is not even or odd. This is neither. 1 minus x to the fourth, so f of negative x will be 1 minus negative x to the fourth, which is 1 minus x to the fourth. So in this case, f of x is equal to f of negative x. That means it's an even function, and that function has y-axis symmetry. Okay. Next, number 4, f of x equals x squared plus 2x. Let's go ahead and replace x by negative x. So that's going to be negative x squared plus 2 times negative x, which is going to be x squared because the negative gets squared minus 2x. It's not same as original function. It's not opposite of original function. So this is also going to be neither. It's not even or odd. This is going to be neither. And this graph will have no symmetry It won't have symmetry about y-axis and not about origin either. Okay. Next, there's a few try me problems. Go ahead, pause for a minute, try these problems, come back and check. So if we replace x by negative x, this is going to be negative 3x plus 2. This is again going to be neither, no symmetry. Next one, we have x squared plus y squared is equal to 1. This one we do know. It's a graph of a circle, which is not a function. We know that. So it's not a function. And it does have symmetry about x-axis, about y-axis, and about origin. So it has all three symmetries, but it's not a function. Not a function. Not a function. Next, we're going to replace the x by negative x. So it's going to be negative x to the third minus 7x. We can pull a negative out. And we can see here, f of x is same thing. F of negative x is opposite of, if I replace x by negative x, I get the opposite of original function. That means this function will have a symmetry about the origin, and it's an odd function. So this is an odd function, and it does have symmetry about origin. Symmetry about origin, and it's an odd function. That was all for this video.